Good, and a test sound, because that stopped working yesterday, which is fun. All right, so let's take a look at this. This is what we did yesterday. Our composition. Thank you. I got you. Especially when I'm walking past, man. Just like, not that mean. I mean, sometimes I'm that mean, but not usually. So when we have problems that look like this, what this is telling us to do is to take our f of, holy chunky pen, Batman. Try that again. There we go. That's a normal size pen. And our g of x, I'm going to do g of x in green. And we're trying to do our f of g of x. So we're going to take g of x and put it inside f of x. So what that means is I'm taking f of x, and instead of an x, I'm going to put in that 5x squared minus 2. So I'm substituting that piece in place of the x. So in our f, what that's going to look like is that's 3 times our x. But now we just said our x is actually that 5x squared minus 2. So what do we do to simplify this? Distribute the 3. So we got our 3 times 5x squared, giving us 15x squared. And our 3 times the minus 2, giving us minus 6. So our f of g of x is 15x squared minus 6. So the right-hand one is doing the same thing, just in the opposite direction. Instead of putting g inside f, we're going to put f inside g. So this is having us do g of f of x. Substituting f of x in place of the x. So for g, means we're going to be doing g of our 3x. We're substituting that 3x in place of the x. So for g, that's going to be our 5 times our something squared. But the thing we're squaring is actually our 3x. So we're substituting the g of x in place of the x. What do we do from here? Square the 3x. So we're going to have our 5 times what? 9x squared minus 2. Can we simplify that more? Because what's 5 times 9? 45x squared minus 2. So our g of f of x. And I'm way at the bottom, but those are our two pieces. This is what we worked with yesterday. So our f of g and our g of f. The order is important. You can see that these are two very, very, very different equations when we do them. The order matters. Questions on these ones? Cool. So while you guys get notes out, we're going to do our SAT practice thingy. Yay. So if they give us a graph that looks like this, and they ask which of these equations could be a line of best fit for this data. So you're given a scatter plot and asked to kind of figure out where our line of best fit could be. And we're given 4 options. What do we think? Any that we like, any that we don't like, any ones we want to eliminate out instantly? What do we notice?
That they all have the same.
They do all have the same number, so our values are not going to be super duper important. We're going to have a 3 or a 0.8 somewhere. Your guess is B. Why is your guess B? Then 3, closer to 3 than 0.8. Okay, I was like, I can see the logic behind that. I can see the logic behind that. Could we eliminate any of these equations that we have up here for any reason? Because there's 4 options and 4 is a lot.
We can probably get rid of C and D because they're negative.
Because they're negatives. What would a negative slope line look like? A negative slope line goes this way. Is our line of best fit going to go that way? No. So because of this negative slope, we know for sure it's not going to be C or D. Like, So what we're really trying to figure out here, and yeah, we could look at those y-intercepts, but honestly, I think it's going to be easier to kind of figure out the vibe of the slope. So when we're thinking about a line of best fit, it's going to be something that looks like that. So find a couple of points. See how it's changing between them. See if it's closer to 0.8, which is really close to 1, or 3. So we're going to do some estimating here. I like this guy because he's right on lines. This one looks like it's right at about 3, 10. And this guy looks like it's at about 4, 13, maybe 14.
I would say 5.
Type.
No, I mean like 5 for the X.
It's right on this line though.
Oh, you're talking about that one. I was thinking about the one above.
Oh, no, yes, I'm looking. Oh, no. Cool. Totally fine. Let me clarify. This guy, 4, and then it's over there. But we could absolutely look at the 5 and 15. That one's totally fine too.
I said 13.
Yeah, that one looks like it's at 13, maybe 14. But somewhere around there. But you could also totally look at the one that you were looking at over here where we're at 5 and 15. That'll give us a very similar vibe. The only problem with the 5 and 15 one is from the line that I kind of sketched in. It's not exactly on that line. It's close to the line, but it's not super on it. Whereas these guys are pretty much right on that line that I happened to draw in. So what is our slope? Let's look between these two. My green and my purple. How much did it change going up here?
1.
The up?
Oh,
The rise. Our rise was 3. How much did it go over?
4.
It was at 3 and it went to 4. It went over 1. So when in doubt on these kinds of lines of best fit, lines of best fit. There we go. All the letters in the right spots. Line of best fit kinds of problems. Sketch it in, if you can. A lot of times on these tests, there will be like a little sketch thing where you can draw a thing with the mouse. Or just pick a couple of points and trace them. See what's closer. There's, let's say, this pair of points might have a slope that's a little bit closer to 1, but that's going to be 2. None of these points between them are going to have a distance of less than 1. So I think our slope's a lot closer to 3 than it is to 1. So I think A is our best option here. I can totally see the logic of our y-intercept doesn't look like it's going to be at 0.8. But since it's a line of best fit and we don't have all of that information, we can't really tell if it's going to be hitting down here closer to 1 or closer to 3. That's awfully estimating. And they're pretty close together when they're coming to 5s. Like, for realsies. So, A or B, I could see the logic behind both of them. Usually when they have these kinds of problems, they are blatantly clearer. Like it would be -3 or 3. So 3 and 0.8 feel like malicious compliance levels of problems. I'm not opposed to a little malicious compliance, but feels pedantic. Okay, so what we're going to be doing today has absolutely nothing to do with scatter plots. Absolutely nothing. And it's going to feel like we went a whole different direction from our composition. I promise the composition will come back in Monday. Okay? We're going to be working with something called an inverse. And this is something we're going to work with for most of the rest of the year. We're going to toss inverses in and out of things that we're working with. So this is one of those things that kind of an important piece. We're going to start out with it being not hard. I promise. So to create an inverse, what we're doing is think of inverse being like inverse operations, adding and subtracting our opposites of each other, multiplying and dividing our opposites of each other. They are inverse operations. What we're going to be making is called an inverse function. So it basically undoes the other equation. It's an opposite in a way. So what we do to find an inverse is, I want eyeballs on me for a second, because I do a visual with this. We're going to find our x. This is my x. We're going to find our y. And we're going to have them change places. Inverse. So we find our x, we find our y, they change places. That's our process. There is a funky looking notation, just like how we have our f of x, f parentheses x. This is f power minus 1. So it goes up like an exponent. That means inverse. That is a notation that gets used for inverse from now until you stop doing math ever. I still use that as inverse notation in my grad school courses. Like, that is a thing that is used universally. There is, but that is actually doing a reciprocal, because it's thinking about a number more so than an inverse. So, yeah. Thank you. So what we're going to do is we're going to find our x, we're going to find our y, we're going to change places. We're going to start by working with those same point functions that we worked with yesterday, and we're going to practice doing it with points, and then we're going to do it with equations. So with points, it's going to feel like I'm tricking you, I promise. Because it's going to feel like it can't be this easy. So we're going to look at the point functions from yesterday. So the same f of x, g of x that we did when we did our f of g of x, g of f of x, those same guys. So here's our f of x, our 1, 2, our 10, 11, our 0, 3, and our 9, 7. And we are asked to write the inverse. Find the inverse. So what we're going to do is we're going to look at every single one of these points. We're going to figure out which one's x and which one's y. So in an ordered pair, it's not hard to figure out. We go x, then y, right? So to create the inverse, what I do is hang on, I gotta change my screen just a smidge. We're gonna write a point that is the inverse of this point. So I find my x, which is 1. I find my y, which is 2. Change places. The 2 is gonna go in the front, which I definitely want to write that as the green. The 1 goes in the back. Then we do the same thing with the next point. My x is the 10, the y is the 11. So I find my x, I find my y, and they change places. So the y goes in the front, 2. The x goes in the back. That is not what that y, what the y is 11. I was in a groove. 10. There's our comma in between and our close parentheses. So we're literally taking our x, taking our y, and having them swap. So for 0, 3, what's our new point going to be? 3, 0. For our point 9, 7, what's the new point going to be? 7, 9. We're going to put our little squiggly brackets on. We're going to say, well, it was f of x. Now it's the inverse, so we say it's the f inverse of x. Or the inverse of f of x, or f minus 1. I don't care how you say it. As long as you can write it, we're good. And you just made your first inverse. Ta-da. On our points, literally all we got to do is switch the x and y. Don't change signs. Don't change who goes with which partner. Nothing else. Change nothing else. Just where the x is, where the y is, swap them. I'm going to practice it again because it feels deceptively tricky. Like the process isn't hard, but we're going, what? And I get that. So we're going to do it again with our g of x from yesterday. Again, same points. I'm trying to make it so we wouldn't have to do too many writing of things. So here's our g of x from yesterday, where we had our 4, 1, our 5, 0, our 13, 9, and our 12, 10. Same guys. And we are asked to find our inverse. So to take this one's called g of x. So to write our inverse, we're going to have our g minus 1 of x. When it's a list of points, we like to have the squiggly bracket. If we can't do the squiggly bracket, I get it. That gives me the vibe of a squiggly bracket. I am totally okay with that. It took me until calculus to be able to draw those things nicely. Because they're weird. And we don't use them all that much. They're just used for sets. So our first point that says 4, 1, what is the inverse of that point? 1, 4. Switch our x and y to 1, 4. Bless you. What is our inverse of 5, 0?
0, 5.
0, 5. What is our inverse of 9, 13? Yes, because I actually read it backwards and read you the inverse because I was thinking at the same time. Because 13, 9 is the point we're given. 9, 13 is the one we want to write because I wrote. You said it exactly like the right way, but I read it wrong. And then our last one, 12, 10, 10, 12. Okay? So with the points, it feels like we didn't math anything. Like it turned into a puzzle. I saw that flash in So with points, it's not really hard. We take our x or y and we switch them. Where this is really going to come into play more frequently is looking at the equations. We're going to be writing inverses of equations. So this is when we're really going to use our x, y switch. So I'm going to give us an equation, and we are going to find the inverse of the equation. It's a very similar vibe, though. So here's our f of x. F of x is 3x plus 2. So what we're supposed to do is we're supposed to find our x and find our y and have them change places. There's not a y in this equation right now. But there is. What is our y? What stands for y in this equation? F of x is y in disguise. He's wearing a cheesy stick-on mustache. Or a finger mustache. That's as hard as he goes in disguise. He is y. He's just dressed up weird. So before we do any inverse steps, switch our function notation to be a y. It helps, I promise. It is a thing we need to do. 3x plus 2. So switch our f of x back to be a y. Then we're gonna find our x, find our y. I'm going to literally circle my x and my y. Them and them alone. Not the 3, not the 2, not the plus, not anything else. No signs, no powers, no nothing. X and y change places. This is the step that technically creates the inverse. My x is going to go where my y was. My y is going to go where my x was. So we're going to write this as x equals 3y plus 2. That's the step that makes the inverse. This guy's just weird math now. It's wrong because we have an x equals instead of a y equals. We're going to solve it back to be a y equals. Because we don't like to have x equals. Because then we want to be able to write it in our function notation, that f minus 1 of x. But then I need a y equals to be able to swap it back. So we're going to solve it around to be a y equals. So what do I do Like, if we knew nothing about what happened over here, I'm a wall. How do I get y by itself? We nothing.
Subtract 2.
Subtract 2. It's like, doesn't matter where this, I wasn't doing that. Doesn't matter where this stuff came from. I just want to get y by itself, and I want my mouse to go away now. Can I make you do it? There. Silly mouse. All right. So I want to get the y by itself because that's how we write equations. We don't write them as x equals, we write them as y equals. So we're going to subtract 2 from both sides. That gives us x minus 2 equals 3y. Ooh, that's small. All right, bigger on the next line. Again, big wall. What do I do to get y by itself? Divide by 3. Divide everything by 3. This guy divides by 3. This guy divides by 3. This guy divides by 3. I'm also okay if you take the x minus 2 and do it over one big 3. When we do that, we get just y on this side. And we have x over 3 minus 2/3, which is unpleasant, but a thing. Like, we could do that. This is our inverse. Like, it's now in a somewhat decent form. We've got a slope-intercept form equation.
Could we keep x minus 2 over 3?
Yes, you could also write it as x minus 2 over 3. Tomorrow we are going to look into graphing some of these with lines, and so it might be easier to do it in slope-intercept form where it's separated like this. But as far as if it's just writing the equation, 100% totally okay. I'm going to erase it though. Because our last thing is we're going to put it back in that inverse notation where we have that minus 1. So we swapped out our f of x for a y. So now I'm going to switch my y back to our function notation, but it's no longer the same function. It's not f of x. It's the inverse of f of x. So our f inverse of x is our x over 3 minus 2/3. All I did was swap our y back out. I'm going to not have that be blue. Swap our y back out for our inverse notation. And we are going to practice this several times because it's weird and awkward. But this is going to be one of those things we work with. We're going to have a whole chapter based off of something we learned that is the inverse of another thing. Okay, questions on the first one of these? Okay, let's practice another one. This one's called g of x. The literal only difference in the letters is just so we can talk about different equations for like our f of g of x, g of f of x. That's the only reason I have different letters. It means the same thing. So our g of x here is 1/3 x plus 5. So our first step, find our y. We want to have that thing. So I'm going to take our function notation, we're going to put it back into our algebraic notation that we're used to, because g of x just is y. It's a weird looking y. He's in disguise. Badly, but he's in disguise. Trying to be all sneaky. He's not good at it. And that's okay. Like a kindergartner trying to do hide and seek. He's behind a set of curtains, but his feet are sticking out. That is how badly disguised y is in this. All right, so we found our x, we found our y. What we do to create our inverse is I'm going to take my x and I'm going to take my y. And they are going to change places. Just those two pieces. No powers, no numbers next to it, nothing added on, nothing. Just the letters. So this is the step that makes the inverse when we write it as x equals 1/3 y plus 5. The x and y change places. This is now officially the inverse. It's just really bad math grammar to write it as x equals. So we switch it back to be a y equals. So what do I need to do to this guy to get back to a y equals? Minus 5 on both sides. So we're going to have our x minus 5 equals 1/3 y.
Maybe you would divide is the next step, but what would you divide by? Because that's a fraction.
I was going to say, you can think of it as dividing by 1/3, or what's the other way we can get rid of a fraction? By the denominator. So when we're having a fraction that's multiplied, the way to get rid of that is you can think 1/3 times what? Or remember that you can always multiply by our denominator to get rid of a fraction. As long as I take whatever I'm multiplying by to get rid of the fraction to both sides. Everybody multiplies by 3. The x multiplies by 3, the 5 multiplies by 3, the 1/3 y multiplies by 3. And you can either write it like this, where you have it as your own little baby distributing problem, or you could write it as, 3 times this one, and this one times 3. Like, that's okay, too. It means the same thing. I tend towards this way because it's much more mathy, and we like to think those things. Ah. Either way, what are we going to wind up with on our left side here? 3x minus 15. And our right-hand side, my 1/3 and my 3 cancel out, which I don't want to do that in purple. There we go. So we're left with just our y. Our last step is to put it back in our function notation. So this guy was called a g of x. So our inverse is going to be the g inverse of x. Or the inverse of g of x. I don't care how you say it. 3x minus 15. Okay. Questions on this one? Because we're going to do one more. And you know how I do. It's going to kick up a notch. But it's okay. We can do this. Because it's not just going to be lines.
Oh.
Sometimes it's going to be the things we've seen before, like, say, quadratics. It doesn't change a thing about what we do. We're just going to have a little bit more steps in our solving. So we've got here h of x. Totally fine. It's just a different name. Equals the quantity x minus 4 squared. That's just a way to read that. The parentheses, x minus 4, close the parentheses, squared. And then plus 1. So the first thing we need to do, thank you, dear. The first thing we need to do is find our y again. Because this has an h of x in it. Ugh. But we want a y to make an inverse. So h of x is in a cheesy disguise. This guy is y. So y equals x minus 4 squared plus 1. We find our x, we find our y, and them alone. Change places. Literally just the letters. Nothing multiplied in front, nothing added on, no powers, no nothing. Can we sense where I often have people make mistakes?
Is that why in the on the first page we looked at it said
Bring no friends. They go alone. They don't take any friends. No numbers in front. Even if this was a 3x, no. They leave their friends behind. They're on their own adventure. So my x and my y change spots. They take no friends. So x equals y minus 4 squared plus 1. They take no friends. Just the letters. So we now have an inverse. It's just gross, because ew. What do we need to do to get our y by itself here? Ooh. Let's not draw wiggly lines. We will eventually, but what do we need to do first? Subtract the 1. Start from our outside and work in. I need to subtract 1 for both sides. So we're going to have our x minus 1 equals our y minus 4 as a quantity squared. Now what are we going to do?
Square.
It's already squared. How do I unsquare it?
Root.
Square root. So to get rid of this square on the y, because I'm like, I need y equals, not y squared equals, I need y equals. This is when we're going to square root both sides. So my square root and my square are going to cancel out, and we're going to be left with our y minus 4 on this side. And my left side, can we do anything with that? Like, can I simplify that at all?
Not really.
Nope. Square root x minus 1. What do we do to get a y by itself now? Plus 4. Am I going to be able to add the 4 to that minus 1 that we have going on here? X minus 1 plus 4. Why can't I add the minus 1 and the 4? Because it's underneath the radical. It's inside the house. To come outside the house, it has to have a friend. Radical land. We graphed a bunch of these last semester. This is where they came from. These are inverses of quadratics. In fact, that was the other half of chapter 6, was when we were graphing those radicals. So our last step on this one, we got to put it back in our function notation. This guy was originally called h. It's a relative of h. It is not the exact same thing as h, so don't call him h again. H has changed. Pick the new name. This is h inverse. We did a thing to change him, so his name is a little bit different. X minus 1 and then plus 4. This is our inverse. Okay. At this point, that's kind of as gross as I get. Questions on that one? Or on any of the ones we've done today, now that we've seen it. Okay. Okay, so I'm going to hand out actually what is the last homework of this chapter. I'll give you guys the first homework on Monday. Tuesday. This is the last homework of the chapter. And you guys can do everything except for the bottom one, but honestly, you could probably figure out the bottom one on the front. We're going to talk about the bottom one tomorrow and probably start on the back. And then Monday, we're going to finish on the back. And that'll be it. It's a very short section. Okay, so here is these. So it's not on the thing, but don't forget that Canvas assignment, that's the SAT practice, multiple choice questions. Yes, it's for points. It's on Canvas. Not my thing, but it's thing you have to do. This is the thing. So you guys have a little bit of time. You guys work on stuff, questions, whatever it is we need. got about 5 minutes till announcements to start.